Welcome to this section of Mr. B's Auto Shop. Today we are going to be discussing the functions and uses of a digital multimeter, sometimes referred to as a DVOM, which stands for digital volt ohm meter, or sometimes just called a voltmeter. We're going to be using two different types. One is an auto ranging DMM, and the other one is a manual ranging DMM. Most of the functions work exactly the same except for the ranging portion, so when we get to the manual ranging, we'll focus on just those sections that are affected by the manual ranging functions. We are going to be using two different snap-on meters. This one is a 540D and this one is a 503D. So this one's a manual ranging and this one is an auto ranging. First thing you need to determine when you use a meter is whether or not the meter is capable of doing the task you ask safely. If we use a meter with a lower rating, you could seriously injure yourself or damage the components you're testing on. If you look at the meter, on the meter face, you can see where we have our category rating. The category is the most important because it indicates the capability of the meter to handle a voltage spike. For the automotive uses, we want at least a category 2 to work on 12 volt cars and a category 3 or 4 to work on the higher voltage hybrids. So step 1, verify that your meter will work safely with what you are testing. The second part that we need to be aware of is the leads themselves. Not all leads are the same. If we look on the leads, we can see that there is a category rating on the leads as well. The leads need to be at least the same category as the meter or greater. And you can see that both the meter and the leads are a category 3 and a category 4. So these meter leads are acceptable. The next part of the lead we need to be concerned with are these tips. Many people take these tips off when they're using them and then they lose them. But these tips are there to protect you. If you use the leads without the protective tips, it drops the category one level. So if this is a category 3, it now becomes a category 2, which will make it unusable in many situations. So you need to keep your protective caps. We also need to inspect the leads to make sure that they are free from cuts. If they have a cut and you're holding it at that location, you could end up getting a shock. It is easy to tell if the leads are torn because they are double insulated, and the double insulation will show white through the red or through the black. So run your fingers across your leads and see if you see any white areas poking through. If you do, you need to replace the leads. The meter itself is protected with a fuse. The fuse is located behind, inside of the case. If your meter is in a case, to access the fuses, go ahead and pull these out. And then you would remove the 3 screws from the back, and then you can access the battery and the fuse compartment. The fuses that are used are not your standard glass fuses. They have to be what is called a ceramic slow blow fuse. These are typically a tube fuse with a white paper coating on the outside. In case of an over amperage condition, the material inside is basically sand and the heat turns it to glass, which then insulates the meter from a further voltage spike. This will protect you from becoming injured in the case you measure something that's greater the amperage than the meter is able to measure. On this meter, we have function buttons. These function buttons are designed to enhance the dial functions. So each one of these functions will work with a selection on the dial. We need now to understand the dial settings. If we look closely at the dial settings, you will see that this first one has the letter V, and then it has a sine wave above it. That sine wave indicates that we're measuring AC voltage. If we move to the next selection, you'll notice that we have the V symbol with a solid line and a dotted line underneath it. This measures DC voltage. The next selection is a little m with a large V, and that stands for millivolts, or thousandths of a volt. The symbol above it is a sine wave with a solid line above it, which means it can measure both AC or DC. But you have to tell it what you're measuring. If we look in the upper corner, we can see that it says DC. To change it, I would then click the AC/DC button. When I push the AC/DC button, you can see that I'm now going to be able to measure AC. If I push it again, I would then be able to measure DC. The next setting we have is the ohm symbol for omega. And above it, we have a speaker symbol. And then we have the symbol for a diode, which is an arrow basically running into a wall. A diode is a one-way gate, so it'll allow electricity to flow in one direction, but will not allow it to flow in another. If you have an LED, that is also a diode, but that diode produces light. It will only produce light when the electricity is flowing in one direction. The other direction, it will remain unlit. How do we select between ohms, continuity, and diode? By pushing the ohms continuity button. So right now you'll notice that my display just shows the ohm reading. Now I have the continuity reading, which will allow us to measure if a circuit has the ability to conduct electricity. If I push it again, it now shows the diode symbol. Now there will be future programs that will go through using each one of these settings, but for right now we are just getting you familiar with the multimeter. The next we move over to, we have Pico Amps. This is typically used with computers and things like that, not very often on the automotive industry. And you'll notice that above it, it only has the solid and dotted lines. So that means that it is only used for DC amperage. We move to the next one. And we have microamps. You'll notice that you have the sine wave and the solid line. So once again, this one is able to measure AC and DC. And once again, we will use the AC/DC button to cycle between AC and DC. The next setting that we have is milliamps, or thousandths of an amp. And once again, above it, we have the sine wave and the solid line, so we can toggle between AC or DC. The next setting we have is amps. The maximum range of this meter is 10 amps. So you must be careful that you're not measuring a circuit that is drawing more than 10 amps. Otherwise, you can damage the fuse or cause an issue with the component that you are measuring. It is also toggleable, so that we can toggle between AC and DC with that setting as well. The next setting that we have is HZ, which stands for Hertz. This one is also toggleable between Hertz and duty cycle. Hertz is how often something happens per second, and duty cycle is a percentage of on time compared to off time. So if you wanted to know how long a sensor was on versus the sensor being off, duty would be the correct setting. If you wanted to know how fast something is happening, then you would want to use Hertz. The next selection we have is capacitance, and the capacitance measures the ability of a capacitor to hold a charge. So these are the dial settings, and these are the function settings. We will cover these in more detail when we cover each specific section. The next part of the multimeter or DMM that we have is our ports. You'll notice that 3 of the ports are in red and 1 of them is in black. The common lead will always go in that location, and then we will select the correct spot depending on our measurement. So the one to the farthest right will measure everything except for amperage. In this one will measure milliamps, and this one will measure amperage. So it is very important when you're using these to not exceed the ability of the meter. It will cause the fuse to blow, and the fuses can be quite pricey. So this is the Snap-on 504 auto ranging meter. We're now going to look at the 503 manual ranger. The only difference between the 2 meters is this does not have the function buttons. Those selections are now on the rotary dial. The difference is, if you are unfamiliar with electricity or working with it, sometimes it's easier to use an auto ranging meter because it will select the correct range for what you are measuring. This meter can be easier to use and faster if you understand what setting it should be. If you are in the wrong setting, the meter will read OL, or in this case, it reads a 1 space decimal. That's a non-sensible number, so that indicates that we are out of the range of this setting. If that was the case, we would continue to move upwards until we got a reading. Once we got a reading, then we would know we were on the correct range. If we're measuring voltage, we typically start with what we expect. The range is the maximum that scale will read. So this scale will read no more than 20 volts. So if I'm working on a diesel truck that has a 24 volt system, the 20 volt scale will show this. If I move it to the 200 volt scale, I then would get a reading of actual numbers that is understandable. So that is the biggest difference. Other than that, they work the same. We use them the same way, just a different way of accomplishing the same goal. So this concludes our introduction to DMMs or digital multimeters. In the next video, you will learn how to measure AC and DC volts, as well as measuring voltage drop. Thank you for watching Mr. B's Auto Shop, and I will see you in the next session.